Welcome! Today we are diving into one of the most incredible stories ever told. It's not science fiction, it's the blueprint for life itself. We're talking about human reproduction, the amazing, intricate process that explains how you, me, every single one of us got our start.
So let's just start with the biggest question of all, the one that really frames our entire journey today. How on earth does one single tiny cell become a whole human being?
Well, the answer is nothing short of a 9-month biological epic. It's a story packed with unbelievable odds, split-second timing, and a design so complex it's almost hard to wrap your head around. So let's do this. Let's start right at the very beginning.
To really get this story, you first have to meet the key players. We're talking about the two highly specialized biological systems that make everything else possible.
You see, these two systems have very different but totally complementary jobs. The male system, its whole purpose is to produce and deliver the male gametes, that's the sperm. The female system, on the other hand, produces the female gametes, the ova or eggs, and is also built to do the incredible job of nurturing a developing embryo from conception all the way to birth.
So let's take a quick look at the male system. You've got the testes, which are basically the production factories for sperm and male hormones. They're housed in the scrotum, which has this brilliant design feature. It keeps them just a couple of degrees cooler than the rest of the body, which turns out to be the perfect temperature for making healthy sperm. Then you have a whole network of ducts to transport the sperm and glands that create seminal plasma, which is the fluid that nourishes them and helps them swim.
And on the female side, you have the ovaries, which produce the egg or ovum. The oviducts, you probably know them as the fallopian tubes, are absolutely critical. This is the place where fertilization actually happens. From there, the uterus provides a safe home for the embryo to implant and grow for the next 9 months. And of course, the mammary glands are there to provide vital nourishment after the baby is born.
Okay, so we've met the major players. Now let's zoom way in, down to the microscopic level. How are these two superstar cells, the sperm and the egg, actually made? This whole process is called gametogenesis.
Now, here is a wild fact for you. A female is born with every single egg she will ever have. And by the time puberty hits, that number has already dropped to about 60,000 to 80,000 potential eggs in each ovary. It's a limited supply, and it only goes down from there.
But the story for sperm production, spermatogenesis, is totally different. It doesn't even start until puberty, and from that point on, it's basically a continuous production line. One starting cell goes through a couple of divisions and ends up creating 4 mature sperm cells. It's a non-stop process.
Now contrast that with oogenesis, making an egg. This process actually starts before a female is even born. The cells start developing, but then they just hit pause for years. Then after puberty, only one of these cells per month gets the signal to finish its first division. And it's an unequal split. It creates one giant, nutrient-packed ovum and one tiny little thing called a polar body that doesn't go anywhere.
So when you put them side by side, you can see these are two completely different strategies for creating life. Spermatogenesis is all about quantity. It's a continuous assembly line that starts at puberty and can go on for a lifetime. Oogenesis is all about quality. It's a long, slow, and super selective process that produces just one viable egg each cycle, starting way back in the fetus and ending at menopause.
All right, the building blocks are officially ready. Now it's time for the main event, the moment of union. This is where it all comes together in a game of perfect timing, chemistry, and just incredible, incredible odds.
And everything, I mean everything, hinges on the menstrual cycle. You can think of it as the body getting the stage ready every single month, just in case. But the absolute key moment happens right around the middle, about day 14. A big surge of a hormone called LH triggers ovulation, and that's when the ovary releases a single, mature egg. And there's the target. Just one. This single cell is released and it only has a very short lifespan. We're talking about maybe 12 to 24 hours. The window for this to happen is tiny.
Now look at the competition. In just a single ejaculation, you're looking at 200 to 300 million sperm starting an epic journey. It's an unbelievably tough marathon, and only the absolute strongest and, frankly, luckiest will ever make it to the finish line.
So when just one of those millions of sperm finally penetrates the egg, that's it. That's fertilization. It's the moment these two cells fuse together to create a brand new single cell called a zygote. And that one cell has the complete genetic blueprint for a new human being.
And you know, here's a really cool detail. The egg always carries an X chromosome, always. But the sperm can carry either an X or a Y.
If an X sperm gets there first, the baby will be female, XX. If a Y sperm wins the race, the baby will be male, XY. So, scientifically speaking, the father's contribution is what actually determines the sex of the baby. So, once that first cell, the zygote, is formed, it immediately starts to divide. And divide, and divide again. It's on the move, traveling towards the uterus, and this kicks off the incredible 9-month marathon of development. The speed of this development is just mind-blowing. Think about this. After only 1 month, the embryo's tiny heart has already formed and started to beat. By the end of the first trimester, just 12 weeks in, most of the major organ systems are already formed. Then, around 5 months, the mother can feel the first movements. It's an astonishingly rapid and complex process, until at 9 months, the fetus is fully developed and ready for the world.
And that brings us to the grand finale of this whole epic journey, the process of birth and those first precious moments of life.
The scientific name for it is parturition, and it's not a random event, not at all. It's triggered by this complex and amazing hormonal conversation between the baby and the mother's body. It actually starts with a signal from the fully developed fetus. That signal tells the mother's pituitary gland to release a hormone called oxytocin. Oxytocin makes the uterus contract, and those contractions, in turn, signal the brain to release even more oxytocin. It's this powerful positive feedback loop that just keeps building and building until the baby is finally born.
But the story doesn't quite end at birth. For the first few days, the mother's mammary glands produce this amazing stuff called colostrum. It's like liquid gold. It's absolutely packed with antibodies that give the newborn its first crucial protection against germs in the outside world. So let's just end on this thought. This whole thing starts as a race with 300 million contenders. It results in one single cell, which then multiplies into the 37 trillion or so cells that make up your body right now. When you really think about it like that, isn't the journey to become you the most improbable, most incredible story ever told?